The first module, Part Arrives to System, is a create module. If you double-click it, a dialog box will pop up showing related date. The name of this module is Part Arrives to System. The entity type should have been defined by entity date before it is used here. The key thing we need to define is the inter-arrival time of the parts. Here we can see the inter-arrival time is defined with an exponential distribution with parameter value of 5 minutes. Parts are defined to arrive one by one. There is no limit on the number of possible parts. The time of the first arrival is 0. The same information we saw in the dialog box in the previous slide is also shown in the spreadsheet view. You can either use the dialog box or the spreadsheet view to change a parameter. In the spreadsheet view, you can select a parameter or double-click a parameter to edit it. If you right-click on some parameters, you may see extra options such as Expression Builder, which is used to construct complex expressions. Remember earlier we saw the part entity type in the Parts Arrives to System module. If you click Entity in Basic Process panel, you can see all the entities defined for the model. Here we only define one type of entity, part. If you double-click empty area of the spreadsheet view, you can add a new entity. Here we want to change animation picture to blue ball. The second module in the flowchart view is called Drilling Center. This is a process module. If you double-click it, a dialog box will pop up. The type of process module can be standard or submodel. This process has 3 actions: cease, delay, and release. The actions are working on a resource, the drill press. The drill press has been defined as a resource date before it is used here. So this process module will cease the drill press, use it for a while, and then release it. We need to define how long it takes to process each part. That is defined as delay. Here, the delay time is defined as a triangular distribution with a minimum of 1 minute, a maximum of 6 minutes, and a mode of 3 minutes. The mode is the most likely value for the delay time. The actions do not have to include all 3 steps: cease, delay, and release. Other combinations are possible under different circumstances. You may choose which one you want based on your actual problem. Besides triangular delay type, there are other delay types with different parameters. We need to use input analyzer to determine the delay type. In the process dialog, if you double-click the resource, another dialog box will pop up to show you the resource. You can add, edit, or delete resources. In this slide, the upper figure shows the process date in the spreadsheet view. If you click the resources icon in the basic process panel, you will see the resources as illustrated in the lower figure of this slide. The spreadsheet view for the resource gives us detailed information about resources. You may double-click the empty space to add more resources. It is just like adding a new row to a spreadsheet. A queue is shown at the long line before the machine in the flowchart view. The parts should wait in the queue if the drilling machine is busy. If you click the queue icon in the basic process panel, you can see the details of the queue. This queue is named as Drilling Center queue. The queue type is first in, first out. As introduced earlier, both the queue and the resource can have animated representation in the flowchart view. The queue animation that is, the long line, is automatically added if you specify cease action in the process delay. The resource animation, in this case the machine icon, is added manually with the resource button in the animate toolbar. If you double-click the machine icon, it will bring up a view where you can define the animation details. You may assign different pictures for different resource statuses. For example, if you assign a picture for machine idle status and another picture for machine busy status, there are other built-in pictures available in Arena. The third module is the Dispose module. If you double-click it, it will launch a dialog box for you to name it. There is not much you need to change though. You may have noticed that modules are connected by thin lines. To add lines, you need to first click Collect button to enable the line connection mode. The option Auto Connect is enabled by default, with it being enabled when we add new modules into the flowchart view. Connections may be automatically added. You may delete a connection if that's not what you want. The other option, Animate Connection, is useful for generating animation of entity movement between modules. You will find out this is a very nice feature. In the flowchart view, we noticed that there are two dynamic plots, one for number waiting in the queue, the other is to indicate machine status. We can certainly add more plots to dynamically plotting the changes. Do you remember that we had two similar plots in the manual simulation? If we double-click the plot, a dialog box will pop up. It allows us to edit the expression and the parameters for the plot. This is a dialog box for defining the plot. There are many options, but most of them are self-explanatory. The most critical thing is to define what parameter you want to display. When you click Add or Edit, you will see Plot Expression dialog box. It allows us to add the expression. Some expressions may have been figured out and suggested by Arena. If you want to have more, you may use Expression Builder to define more specific expressions. There is a topic label at the top left corner. The label is drawn with simple draw tools in the Draw toolbar. Another useful toolbar is the Arrange toolbar. It allows us to better position objects in the flowchart view. If you don't see the Arrange toolbar, you may right-click any current toolbar from the context menu. You can toggle different toolbars. If you want to use some toolbars, turn them on, otherwise turn them off. Before the model runs, we need to do some setup. This is done through the menu Run Setup. It will pop up a dialog box where we can set the run parameters. There are 7 tabs. At this moment, let's focus on 2 tabs, Project Parameters and Replication Parameters. The checkboxes of statistics requests will determine what will be reported after the simulation runs finish. Simulation is usually run with many replications, as we have seen in Chapter 2. In the Replication Parameter tab, we can define the parameters for replications. We have gone through the model. Now we are ready to run the model. Click the Go button to run it. If the model has no errors, Arena will run it. Otherwise, it will not run and will report errors. There are a lot to watch during the simulation. If the changes are too fast, you can slow it down by dragging the slider in the standard toolbar. After a short while, the simulation finishes. and a message box pops up in the run setup, we only specify one replication, so this only runs one replication. The model remains in the run mode unless you press End button. If you notice that some menus or buttons are disabled, it probably means that you are still in the run mode. We can click Yes to view the results report when the simulation run ends. If this is your first time to view the report, Arena will try to install Crystal Reports, a software package for report generation. After a while, the report is displayed. The generation date are stored in a Microsoft Access database. You may see it from the book example folder. The Crystal Reports software can generate reports from the database. The view of the reports is quite self-explanatory. You may find out there are some insufficient date items. This is because we only ran one replication. It is not enough to generate some statistics. You can export the report to many other formats such as PDF, Word, and Excel. There are a lot of information presented in the simulation report. The result cover the queue, the entity, the resource, and the process. These results are similar to what we got in Chapter 2 for the same model. We shall recall that there are three types: tally, dstat, and a counter. As an alternative to the Crystal report, we can generate a more compact report as a text file. This option can be set in the Reports tab of the Run setup. Simon is a simulation language. Arena is built on top of Simon language. These slides show an example simulation report in Simon text. It is more compact, with the same amount of information as a Crystal report. We only ran one replication of 20 minutes. We can make it longer than 20 minutes. If we want to run it for a long time, we need to consider other factors such as warm-up period.